question is from GATE 2016, Mechanical Engineering paper, set 2, question number 36. The rod AB of length 1 meter shown in the figure is connected to two sliders at each end through pins. The sliders can slide along QP and QR. If the velocity VA of the slider at A is 2 meter per second, the velocity of midpoint of the rod at this instant is dash meter per second. Let's understand the system that is given. Point A of the rod is moving by velocity VA. B also will have to go further, and it is restricted to move only in this direction because there are guided rollers here. Let's mark VB in this direction. Now, as the 2 points are going in different directions of the same rod, the rod is also subjected to an angular velocity omega that can be found out by finding the instantaneous center. So I have drawn perpendiculars to the direction of velocity at points A and B, and the point where these perpendiculars meet is nothing but the instantaneous center I. Now in this figure, we have this angle to be 90 degree because this is 90, this is also 90. This angle is already given to be 60 degrees because the base angles are both 60, this one is also 60. So the remaining angle, that is angle IAB, will be 30. Same is the case at the base. So this is 90, part of it is 60 given, so this one will be 30 degrees. Triangle IAB is thus an isosceles triangle, and therefore we say IA will be equal to IP. Now in such an isosceles triangle, if we drop a perpendicular from the opposite vertex, it will divide the base in two halves. That is why this will be the midpoint of the rod M. We have to find the velocity of this midpoint. Now we know that angular velocity of the rod omega, let that be omega, is equal to absolute velocity of point A, VA, divided by distance between A and instantaneous center, that is IA. It will be also equal to velocity of point B divided by IB, and of course it will be also equal to velocity of point M divided by IM. It's true for all the points on the rod. Now we are interested in this and this ratio. So let's write it separately. VA by IA is equal to VM by IM. We need to find out VM. Keeping VM on one side and taking all the terms to other, we have VM equal to IM by IA into VA. VA is known to us to be 2 meter per second. We need to find this ratio IM by IA. Let's look at the triangle IAM. In triangle IAM, we can write IM by IA marks this opposite side by hypotenuse ratio. That is nothing but sine 30 degree. The side opposite to 30 degree is IM and hypotenuse is of course IA. So we can write this as sine 30 degree into 2, which will be 1 by 2 into 2, 1 meter per second. We have velocity at point M, which is the midpoint of the rod, is 1 meter per second. Let's fill in the answer. Velocity of midpoint of rod at this instant is 1 meter per second. To learn more about instantaneous center, you can refer to the NPTEL video, lecture 21, velocity analysis, method of instantaneous center 1, from the course Kinematics of Mechanics and Machines. It is by Professor Anirvan Dasgupta. He is from Department of Mechanical Engineering, IIT Kharagpur.